Right, good morning. This is feedback on the end of year exam that you took when you first started back in September. I've done two separate videos, one for multiple choice questions, one for extended questions because it was quite a long exam and you obviously don't want to be trawling through a great long video for questions that you might be interested in. So let's make a start. Let's have a look at question one. Note obviously that it's asking you which statement is not correct, so three of them will be correct, and really basic information here that elements in halogen group don't increase in reactivity down the group, they get less reactive. Okay, bond angles here. I've written the bond angles for each one. Don't forget the rules for working out bond angles. You're looking for areas of electron density around a central atom, and don't forget you have to include lone pairs. So the answer was A, because I've shown you the other angles. The percentage composition by mass of nitrogen, pretty straightforward. Obviously there are two nitrogen atoms in this compound, then just add up all the rest and divide by that number times 100, and that'll give you the answer. Question 4. So looking at atom economy and the sustainability of each reaction. Remember, atom economy is only looking at the products, so you're adding up the masses of all of the products and dividing that number into the mass of the useful product. So it says sustainable in terms of the atom economy of the organic product, so it's only the organic product you're interested in each equation. Obviously you just have to add all the rest together. I've done it for all of them just to show you how the answer was arrived at. This one, question 5, this could make you think a bit, I think. So you're adding together 8 cubic decimeters of nitrogen oxide, 6 cubic decimeters of oxygen, allowing them to react, and then one of the reactants will be used up. So that's the clue that you're looking for, the limiting reagent, or the one that's in excess, I should say, in a way, because that's what you need to know here. So you work it out that oxygen is in excess. So oxygen, because oxygen is in excess, we are going to get the same number of cubic decimeters of our product as the nitrogen oxide. Yeah, because we're going to have some oxygen left over. So all of the nitrogen oxide will be used up. Okay, sorry about that. Seemed to be a bit of a blip on my computer there. So just going back to this. So oxygen is in excess, which means that all of the nitrogen oxide will be used up. So you're going to get the same volume of nitrogen dioxide. But because you need half as much oxygen as you do nitrogen oxide, you only need 4 cubic decimeters of it. So 2 cubic decimeters will be left over. So you've got 8 cubic decimeters of NO2 plus the 2 cubic decimeters of oxygen that weren't used. So the answer is 10 cubic decimeters. Okay, question 6. This is the ideal gas equation. Yeah, and don't forget, let's have a look, you need to convert your Celsius to Kelvin, and you need to convert your kilopascals to pascals. Okay, and then just rearrange the equation and slot it in. Question 7. Okay, you're given a mass of an element X, told it's reacted with a number of moles of chlorine molecules, note, to form a chloride with XCl2. So basically it's 1 mole of X to 1 mole of chlorine. Just don't forget chlorine exists as a diatomic molecule. So because the ratio is 1 to 1, it's pretty straightforward to work out that it's magnesium. So you work out your molar mass, your relative atomic mass, or mass actually, of the substance X, which is 24, which is magnesium. Okay, we've got phosphate ion has formula PO43-. Hence, what is the formula for copper 1 phosphate 5? So if it's copper 1, then that means it's Cu+, and obviously PO4 is 3-, so we need 3 coppers for every phosphate ion. Which reaction shows chlorine only being oxidized? So obviously you just have to quickly go through them to recognize where chlorine is only being oxidized in the last equation. In all of the other equations, it's being oxidized and reduced, called disproportionation, remember. Okay, question 10. Which statement about this reaction is correct this time? Okay, so remember that activation energy, when you're looking at an enthalpy profile diagram, is always measured from the reactants. So in this case, so for the forward reaction, obviously it's from here, 150. But if the reaction is going in reverse, so that our we have to put our products at a higher energy than our reactants, then you'll add the two values together. Okay. Okay, oh yeah, so which statement about this reaction is correct? I mean, if you go through them, you should be able to highlight which ones are not correct. But definitely, if a reaction is reversed, because of the law of conservation of energy, if energy is released in one direction, the same amount of energy must be absorbed in the other. Okay. The main reason for the increase in reaction rate with increasing temperature is because, well, as it says here, it's pretty straightforward. More molecules have an energy greater than the activation energy. None of those other. I mean, this is true, but it's not the main reason. Yeah, this is the main reason. It does state main reason, and it's in bold letters. Okay. Right. What? In an equilibrium, if you add a catalyst, the forward and reverse reactions are increased. The rate is increased by the same amount. Bonding in an ethene or an alkene, you have one sigma bond and one pi bond for the double bond. Unsaturated, alicyclic, and contains an alkyl group. So unsaturated means it must have a double bond. Alicyclic means it must be a ring, and an alkyl group is just a chain with a carbon and hydrogen. So that's what you're looking for. So here, this is obviously not got a double bond. Neither is this. Neither is this. Well, this has got a double bond, I suppose, but it's not an alkene, is it? So it's got to be this one. Yeah, definition of an electrophile. Basically, you know, electrophiles like electrons, so it's an electron pair acceptor. This seemed to confuse a few of you. Which monomer would form this polymer? So you've got to work out which is the repeating unit, and I've just written the H's in just to sort of highlight it to you why it's this monomer, for those of you who weren't sure. So each repeat unit goes from here to here, and then here to here, yeah? And so hopefully now you can see that that is the monomer. Which compound is not likely to have a fragment at 43? So you're looking to see which ones do have fragments at 43, and all of these are fragments that add up to 43. In this one, of course, you can't make a fragment that adds up to 43. Infrared radiation, we're looking for an incorrect statement, and in the upper atmosphere, the destruction of ozone is carried out by the action of ultraviolet light on the carbon-chlorine bond, so not infrared. And then finally, with the multiple choice questions, Yeah, this one was a bit of a trick question in a way, because it made you think it was a carboxylic acid, because you've got the C double bond O here and you've got the OH. This actually isn't broad enough. And if you look on your data sheet, which you should always do when you're looking at spectra, you'll see this isn't broad enough to be a carboxylic acid. So they are really testing your understanding here of the infrared spectrum. So it's an alcohol, that's the alcohol group, and it's got a C double bond O, so it's got to be B. Okay. I'll complete the other video in a second, so that if you want to look at the extended questions, you can.